All right. Well, welcome everyone to 24 Hours of PaaS, Growing Our Community Edition. We're excited you could join us today for Ginger Grant's session, Data Analysis into SQL Server with Azure Machine Learning. This 24 Hours of PaaS event consists of 24 consecutive live webcasts delivered by up-and-coming speakers and experts from the PaaS community. All sessions will be available next week on 24hoursofpaas.com. My name is Aaron Nelson, and I'm the chapter leader for the PowerShell virtual chapter of PaaS. I have a few quick introduction slides before I hand the reins over to Ginger. She will speak for 40 to 45 minutes, and then we'll move on to Q&A, where you can ask any questions you may have. If you're having any issues, just type your question into the question pane on GoToWebinar control panel, and someone will assist you. To maximize your screen, use the Zoom button located on the top of the presentation window. Feel free to enter your questions into the Q&A field at any time. The questions pane is located on the right side of your screen. Once we get to a Q&A portion of the session, I'll read off your questions to the speaker. Since all attendees are muted, you will need to submit your questions by typing in the Q&A field. Note that there will be a short evaluation at the end of the session. Your feedback is important. Please take a moment to complete it. It will show up on your screen once the session is over. I'd like to take a moment to thank our presenting sponsors, Microsoft, Cisco, and Dell Software. In addition, I'd like to thank the support sponsors for this event, SQL Sentry, HP, and SolarWinds. Staging 24 Hours of PaaS would not be possible without their support and dedication, and they are the reason that this event is free of charge. Next, I'd like to bring your attention to the upcoming PaaS Summit taking place in Seattle, Washington from October 27th to October 30th. PaaS Summit 2015 will feature over 200 sessions with world-class SQL Server experts. Planned and presented by the SQL Server community for the SQL Server community, PaaS Summit is single-handedly the largest gathering of SQL Server and BI professionals. With over 5,000 attendees from all over the world, PaaS Summit is also a great place to network and meet face-to-face with experts, peers, and MVPs like myself. More importantly, PaaS Summit delivers on providing you with the answers to your SQL Server issues, along with the knowledge, strategies, and skills you need to stay ahead of the curve. Contact your local chapter for a discount code and save $150 off of your registration. Optimize your savings by registering before the end of Sunday, July 12th. To find out more about PaaS, visit PaaSSummit.com. And now, please allow me to introduce the speaker of the hour. Ginger Grant is a business intelligence consultant. She's active in the SQL Server community and has worked with SQL Server for over 10 years. She's an aspiring data scientist and will be attending this year's PaaS Summit. Ginger, take it away.
Thank you very much, Aaron. I'm really excited to be able to talk about machine learning because I really am excited about the topic. I was asked recently, what is machine learning? I had an answer, but I don't think it was a really good one. I said it's like data mining on steroids. Well, data mining can be a part of machine learning. It kind of misses out on part of it. So I thought about it for a while, and I think I've come up with a better definition. Machine learning is actually analysis through pattern recognition. For many of you, that's just another flavor of what you do every day with SQL Server. The difference is the methods or algorithms used for the analysis. Since machine learning started in academia, they use more academic sounding terms like algorithms instead of pattern matching. Machine learning uses the algorithm to create groups of data, and companies are now able to apply these algorithms very quickly and use the results they gather to improve upon the grouping that they do next. That's what makes the machine learn. And this type of analysis is used in all sorts of decision processes to do things like determine the odds of something being true, such as, hey, is this email spam or is it not? Or some more kind of predictive analytics, how many widgets do we think we're going to sell next year? This kind of logical analysis has been studied for years. The difference now is the tools, like the ones we're going to talk about today, Azure Machine Learning, and make implementing this kind of pattern recognition so much easier, and allows for this kind of analysis to be integrated with SQL Server. And today I'm going to get to tell you why you want to use machine learning and the most popular kinds, and then move on to further defining machine learning and let you know what you can do with it. So one of the reasons machine learning has become a very popular tool is organizations are moving to implement data-driven decision-making. What is that? Well, data-driven decision-making is usually undertaken by a means of gaining competitive advantage. The study from MIT found that organizations that make their decisions based on data have a 4% higher productivity rates and 6% higher profits. Well, that got people's notice. But one thing I want to throw out there is there isn't a panacea or magic wand that you can do to make the data-driven decision-making work. It still can be wrong. If you have a lot of data, and chances are you do, as more and more data is being stored every day because it's cheap, so people are doing it. You need to analyze what's the right kind of data that you can select that can prove the answer that you're looking for is correct. And in machine learning, they have a term for picking data that automatically, selects the conclusion you expect, and they call that overfitting. That's when machine learning looks at the answers, and then they automatically just say that the model is correct. That can be a big problem, so it's really important that needs to be done correctly. Done well, though, data-driven decision-making is much better than its predecessor, which, even if you are unfamiliar with the acronym, HIPPO, I bet you're familiar with the technique. So HIPPO stands for highest paid person's opinion, and it's what people tend to do if they do not make their data decisions, use data to make their decisions. So while machine learning is used to assist in the decision-making process at a number of different levels, there's a certain type of decision-making process that sort of sucks the air out of the room when it comes to machine learning, and that's predictive analytics. Predictive analytics is divining the future outcomes with data. Mankind has always been looking to predict the future. Predictive analytics is much better than like crystal balls to determine the future because it uses actual data. The goal is to determine what the outcome is that you can be prepared when you get there. So to be able to perform predictive analytics, machine learning looks for patterns of data which have occurred in the past, and then adds a component of probability to statistically determine, hey, is that going to happen in the future? Two things that are really important to evaluate if you're going to create machine learning models for an experiment. First is to define really, really clearly what you're going to do and make sure that you have data to support it. And if you've ever read bond or stock prospectus, you'll probably be familiar with the catchphrase, past performance is not indicative of future response. They tend to say this information right before they show you the performance numbers. Well, statistically speaking, they're right, but that's only because the price number is only one component about what made that successful. For example, if you're looking at a fund and the fund manager just quit, heck, all the past data that they provided isn't relevant anymore because it's the different variables that have been introduced. This can happen, and it's something that you constantly need to evaluate. One of the most popular predictive analytics models that I'm sure lots of people are familiar with are FICO scores. FICO or Fair Isaac is a scoring model used to predict credit, and specifically this is used a lot to determine whether or not you're going to whether or not you're going to be a good risk for a mortgage. Well, statistically speaking, people who pay their credit cards on time, which generates a high FICO score, are well educated and have a household income at least 25% higher than the median, are considered very low risk, except for the fact in the last economic downturn, these people were more likely to default on their mortgages than people who had a lower FICO score. So obviously this means that the model needs to be tweaked, which is something you constantly need to evaluate when you're doing machine learning, is whether or not the model is still complete and correct. And it's, while predictive analytics is really popular, it's only one kind of results learning that's possible with machine learning allows to do many different kinds of analysis as well, such as anomaly detection. Anomaly detection you're probably very familiar with if you go on vacation and use a credit card 3 times and find out that it's denied. Well, why does that happen? Well, your credit card company is doing predictive analysis, and they're doing it in real time, and they are trying to determine whether or not that credit card charge is valid. And they do that, and if they find that you're in a different area, it flags that that's an anomaly. That's machine learning at its finest right there. And the reason that I put the Super Bowl trophy in here is sometimes you have to evaluate things for predictive analytics that may seem way out of the box. It's not, for example, the winner of the last Super Bowl actually has shown, statistically speaking, to impact the stock market. And you may be thinking, that's just the craziest thing in the world. Well, I'm really unhappy that Seattle lost, and it's not because I'm a huge Patriots fan. But statistically speaking, if the NFC, that would be the Seahawks, if they win the Super Bowl, that means that the stock market goes up. Since the Patriots, an AFC team, won, that means the stock market, statistically speaking, is going to go down. Now, you may be thinking that would be the dumbest reason to either get in or out of the stock market, but it's shown 80% of the time that's true. So whether or not that is because people look at who wins the Super Bowl and then either decide or buy or sell stocks, it doesn't really matter. What does matter is 80% is much greater predictive model than most market analysts are able to do. As a matter of fact, that's extremely good rate of return. So sometimes you have to think of really outside of the box algorithms and variables in order to determine your predictive analytic model, and it's important to include some kind of wild things sometimes within machine learning. So what is machine learning? Well, we've talked about sometimes why you want to do it, so you could drive decision making on data and perhaps use that to determine future trends by developing models which can predict the future. But machine learning can do a lot, although the future predictions is the most popular reasons. Machine learning is actually a type of artificial intelligence. It looks to classify data and statistically look at how different variable changes make the data outcomes change. To do this kind of analysis, what machine learning is doing under the covers is organizing and classifying data. And depending on the type of analysis you're doing, you may compare what you're doing to a known result, although that's only one of the models that's possible. You might make decisions based on a trend and use future data to evaluate whether or not over time that trend is the case. That would be an unsupervised model, which is something else you can do with machine learning. It's got a lot of possibilities, in addition to driving robots and Google's cars. So there's some basic categories that you might want to consider if you're looking at creating a machine learning model. One of them we kind of talked about already for anomaly detection. Anomaly detection is looking to see if a transaction is an exception to a general pattern, so it's classifying a certain kind of transactions outside of the norm. Another example, also dealing with credit cards, is I went and bought a lot of furniture recently, and I don't generally use my credit card much, but all of a sudden I had a $5,000 charge, and they called me. Why? Because I generally don't spend $5,000 at a whack on a credit card. They called me to make sure that it was really me doing that kind of charging. Anomaly detection. Classification, that's what we're going to be doing in our example. That's where you look at a series of variables, and based on the pattern of all these variables, you determine an outcome when they're analyzed together. There's two main kinds of classification. One of them is binary. You're looking, a light switch sort of outcome. It's either true or it's not true. And if you're looking to determine whether which of a set of conclusions is possible, that's a classification as well, but that's known as it's of course not binary if you have multiple, so that'd be multi outcome analysis. Regression. This type of analysis is to use to identify trends over time. It's something people look at, for example, for housing prices. They look to see if historical trends, if people want 3 bedrooms or people want 4 bedrooms, and looking at that to determine what the upcoming trends are. So regression is basically looking at data over time. And knowing about what kind of answer you want to determines what kind of categories of machine learning that you are going to be wanting to do. when it's possible to use a whole bunch of different algorithms to create a machine learning solution, if you want to directly integrate the solution with SQL Server, Azure ML is a pretty good tool for being able to do that. Microsoft has designed the Azure Machine Learning tool to be used for really advanced machine learning functionality, but they also know that a lot of people are just starting to get started, and so they include a lot of things that allow you to do that very quickly. The list of the items here on the right are all of the models that it includes natively so that you can select them without necessarily having to know what they all do. You can say, well, why would I do that? I don't know what my outcomes are. The outcome provided to you in a series of graphs so that you can determine the effectiveness of your outcome without necessarily knowing or having to know the underlying information in it. So it's kind of a neat way of doing it. But you're not limited just the more common analytical models. Microsoft knows that a lot of people have been using various machine learning tools for a while, and they want those people to start learning Azure ML as well. So you have the ability to select other models. As a matter of fact, there's even a library of existing models out there so that you can look to see if somebody else has created an algorithm to solve a problem similar to the one that you are looking to solve. You are not limited to the catalogs that you may have or may find from others, because a lot of this is open source, but you also have the ability to develop your own algorithm with R or Python. R is getting to be very big in the data analytics world, and since Microsoft bought Revolution Analytics, which creates R, and R is going to be part of SQL Server 2016. So more and more people are getting involved with doing data analysis and discovery with R. So R allows you to use existing open source libraries, and there are a number of them because R was a statistical language that was created for doing data analysis. You can modify the code in line to work with it just like within an Azure ML experiment, and you create a visualization, because that's one of the things that R does. R not only analyzes the data into memory very quickly, but it also creates a series of graphs, and these graphs are available to you within the machine learning experiment. And the reason you might want to include some of these graphs is if you want to include a different kind of pictorial representation of how the result looks. Microsoft does include just several basic charts to determine the results, but if you want to do something custom, something that you think better depicts how the results compare to the known, you can do that with R. So I've included the Microsoft Azure Machine Learning Algorithm Cheat Sheet. This is widely available on Microsoft's Azure ML site, and I know you really can't see it very well here, but I'm hoping that you will go to their site and look it up so that you can determine how you can pick what you need to do based on a series of decision and knowledge about your data. And the most important thing to be able to do really effective machine learning is knowing your data and knowing your data very well. One of the things that machine learning does require, it requires a very clean set of data. I know a lot of times when you do analysis, you find out some of your data is terrible. I was at a client recently and they found out that last month they had negative $100 million profits. I said, is that really true, or is this report wrong? They're like, yeah, we probably need to go fix our accounting system to make sure that we aren't allowed to enter numbers like that. Well, problems with like that are things that you're going to have to know, because that kind of data will greatly skew the results with Azure Machine Learning. So you can only include very clean data. Information such as this cheat sheet will determine which algorithm you need to use. What kind of problem are you trying to solve? I mean, like any tool, Azure Machine Learning is only good as the analysis that you do prior. You need to know what kind of information that you are that you have, and then what kind of outcome you're looking for to see whether or not your data even supports it. I was at a client recently and they wanted to do some really interesting analysis, but they're looking at their data and they found out that they don't collect it in the granularity that would be necessary to do the analysis they wanted to do. Well, there's no sense in finding out that information once you're knee-deep in a project. You need to discover that first. That's why people with a SQL and a data background, I think, are really uniquely positioned to do very well with machine learning and kind of take it away from where it's traditionally held in computer science, because it's about data classification, and that's what we do. So when we're doing a machine learning experiment, for a binary, for many times what we're doing, if we're doing this kind of analysis, what we're doing is that we're splitting the data into two groups. And the reason that we're doing that for our binary classification example that we're going to do today is we are trying to determine how well that our algorithm comes up with the same result as actually happened. So what we're looking at is we're looking at how a series of variables or inputs, and based on those inputs determines how the outputs are. And this is done all the time. For example, I know this is illegal in some states, but a lot of times people look at credit scores to determine what kind of rates that they are going to give people on insurance, because the variable that they have input is, here's another statistic that they pull out for insurance costing. If you are a male under the age of 25 and you have bad credit, you will have a very high premium. Why? They've done analysis over time and determined those variables are causal. If those two things tend to mean that that person is going to have a higher number of accidents. So it's input that has a greater probability of output, and that's the kind of analysis that we can do with machine learning. So we're going to split our data into two groups, and one of the groups is going to be our control group, that basically is what happened in the past, and the other group we are going to weigh the variables and see how close we get to the actual outcome that occurred. And we're going to test the model and evaluate the results. So there's several ways that you can integrate machine learning into your current environments. Yes, machine learning is a cloud-based Azure tool, but it doesn't have to stay there. One of the things that Microsoft makes available is you can actually put the model into Excel. So using Excel, you can call the algorithm so that you can enter the inputs and get your output. The reason that it's able to do that is at the conclusion of the model, what's created is a web service, and this web service can be called within a number of places. You can also take this web service that is called and put it in a web application that you have, so you can call it within your code. So so once the model is complete, you have a component with a set of outputs that you can use in a number of different environments. Of course, one of the environments is in Azure. One of the ways, unfortunately, I wish I had more time to talk about it, but with the time allotted today, I won't be able to do that, is to implement it with Data Factory. And if you do that, what you are going to be able to do is take your data from SQL Server, load it to Azure, process it, and determine getting your input variables, getting your probable outcome, and then writing it back to SQL Server. The beauty of doing this is for people who don't wish to store your data in the cloud and are kind of reticent to kind of migrate in that area, you're not necessarily having your data there for very long. You only need it there to process as part of a solution. Of course, you can also use it with streaming analytics so that you can process in real time, which is the kind of thing you would want to do, say, if you were in California. As you know, they've got a big water shortage there right now, and they've got a lot of smart meters. So what they're doing now is they're getting smart meter readings, and if they've got 4 or 5 meter readings in a row that show an abnormally high flow rate, they send people out and they start to investigate to see if there's a problem, or that they can go find somebody. And this is the kind of thing that can be done in real time with streaming analytics, is something also available in Azure. So I kind of talked about the data store. You can also, of course, if you have SQL Server within Azure, you can do it there and store your results in Azure as well. Data Factory does provide kind of the ability to do ETL, although it does much more than that. It is an actual pipeline to handle a multiple number of tasks, kind of wider than the ability you can do with what we think of as traditional ETL, and some of those things also involve machine learning. So I do kind of want to talk about how you would bring this up within Data Factory, just to give you an idea of the kind of work that would be involved in doing this, because I unfortunately won't have time to show it. So what you would do is you would start with a data source within Well, first you have your data source, which either comes from either an Azure data source, such as a blob or a streaming service, or even an on-premise database, because if you have an OData feed, you can definitely connect your data from an on-premise solution into the cloud within Data Factory, and then you take your data once it's been defined, and then you create a pipeline. And in this pipeline is where you define that you wish to call a machine learning task. And the machine learning task would, of course, have a variable input that you would provide with your data, and your output would be your result, your probability. Generally speaking, it's a number between 0 and 1. It's generally some fractionalized part of a number 1, so basically like 0.947 or something less than that, to see what's a probability of the outcome that is going to be discovered. All right, so now I'm going to get into looking at machine learning. So for those of you who are not familiar with Azure Machine Learning, I've got my model up here, but I wanted to start off with home. People who are scared of Azure and think, oh great, now I'm going to be in for a lot of money. Not true. This is an absolutely free tool. Of course, when you get into loading data into Azure and using streaming, that will start costing you money. But to develop and test and train models within Azure will cost you exactly nothing. So there's no barriers to entry and no reason why not to get started. This is the home page that you will see. Another thing that they have in here is a lot of videos and information that I really encourage you to go look at, because you can find all about machine learning just by looking at this. I, of course, have a free, notice it says free workspace, and I've already logged into it. It just created it using my Office 365 login that I already have. And I'm going to go ahead and look at my experiments. So one of the things, if you look at, when we look at an experiment, you'll notice that it looks a lot like SSIS. I'm sure this was by design. So what we are looking at is that we're looking at an experiment. Unfortunately, I'm not going to be able to test this particular experiment for you today because I have encountered an internal system error and I've contacted Microsoft. So I don't know what that is about, but I have contacted Microsoft, and so that we're not going to be doing a deep dive into this analysis, but I did want to show you how it works. So what this data set that I have here is a series of information from a website. And what we're looking in this web data is that we are looking to see what is the probability and likelihood that somebody will actually click on an ad. I don't know about you, but I never click on ads. So our data came from SQL Server, and it's a bunch of anonymized web data that, hypothetically speaking, let's say that we got from a company that handles our marketing for us, and although we don't have information specifically about the users, we have randomized information that we can look at their trend. So what we want to know is, for the money that we're spending, how much are we getting out of this? Are people actually clicking? The people clicking, what do we know about them? Well, where are they? So this location ID can be sent back to a city, state, or region, so we have a rough idea of where this is. What hour did they do their search, so that we can determine is it more effective to spend money on ads at a certain given point in time? You know, when did they do this? What day of the week? All this kind of information might be important to determine, are we getting good money out of this? Is this effective? Is our ad money actually buying us anything? And the position of the ad, does the position of the ad determine whether or not somebody clicks on it? Now, one of the things about this particular data set is you'll notice that it's huge. And the reason that this is quite large is, out of all this data, there's only 3,000 actual people who clicked on ads out of over 1 million, which, if you think about it, is probably pretty typical, because very few people actually click on ads, if I'm using myself as a guide. But this was our data set that we used. Now, if this data could definitely be stored in an Azure database, which is where I have it, then I use that as a source within my Data Factory solution. But for testing purposes, It is, generally speaking, I do that with a data set and a data set of the CSV. But you can't, it's not essential, but it's generally speaking an easier way to manage it. So if we want to go ahead and look at our data, we can go ahead and click on it right here, and which shows us the data set and what the contents of the data set. Come on. And I'm going to go ahead and say visualize. And when I do that, I get some information about the data. So is-click is what we want to evaluate here. And we can see that there are 2 unique values and hardly anybody clicks. It barely even registers. We've got, and we've got our over 1 million records where most people are clicking 1. We have our position. And one of the things about this data that's unlike a lot of data that you might use from other sources, say a flat file, is this data is pretty clean. Notice we don't, if we scroll up here, we don't have any missing values. I'm going to go ahead and show you some data where there are some missing values to give you an idea of some of the solutions that you can employ in order to be able to use it. Because if we have a row and any of the data is missing, we have to fix it or throw the row. Those are our 2 options. And all of these items here can be used as input so that we can determine if we enter this information, how able we are to predict whether or not this is going to be a valid result or not. But processing 1 million rows in a task is actually going to take a long time. And generally speaking, another problem that we might have with machine learning is while we're testing, if we keep on testing with the same data over time, the machine gets smart and just starts memorizing the answers to the data once we send it to it. So what we're going to do to prevent that from happening is do something that we call partition and sampling. And I'm doing this so that the application will determine the correct, will get a sample for me, because I don't want to take as much time as it would take to process 1 million rows for testing. I want to do a valid test in order to be able to determine that. So if we look at the properties here, we can see that I'm asking for 1% of the information for my test. I will of course be later evaluating it for larger samples, but it does a really statistic random test, which is very helpful. One of the things that I wanted to especially show you is the ability to apply a SQL transformation. Now, while it's possible to write R in Python, I am willing to bet that the majority of the people at this session probably would have an easier time writing SQL than writing R, just guessing. So what we can do is we can actually transform our data with SQL instead of R. So what we're doing here is what it will do is it allows us to do a transformation, as in write a bunch of SQL. So one of my parameters that you'll notice is I had the hour that somebody clicked on an item, and generally speaking, because of the way that the billing is done, they bill it in increments. So I wanted to classify my hours so that I could determine what would be appropriate for me to buy. So between 0 and 4 is considered late night. And that's why I have these various criteria that I'm creating so that I have a category value that I can use in my analysis, because I'm grouping these together for billing purposes. Now what this does is it always calls this T1. So basically anything that I want to do with SQL, I can do it, and it uses a data stream as T1. I can't, but one thing that I will say is this is not Transact SQL. This is SQL Lite, which means that if I wanted to do something really clever, like I wanted to do weekday, which is a SQL Server function, it will blow up. So when you are yes, you can apply SQL, but yeah, that's not Transact SQL. So the SQL that you can do here is pretty much straight ANSI sorts of stuff. But it's kind of nice because the ability to do that is not just limited to R. You can do a lot of the transformation that way. Yes, you can also do it with your SQL when you're bringing it in, but it's nice to have the ability to manipulate the data afterwards using SQL instead of having to write a bunch of R. So one of the things that's important to do with our data is basically do it various classifications. So I'm going to show you some of the preparation that we need to do in order to run an experiment. One thing that's kind of nice is you can move these windows back and forth in order to either add or remove time, so I can show you something about the data. And one of the things that's important to know when you're doing kind of analysis is if something is considered a number or a category, because it'll be evaluated differently depending on what the answer is to that question. So if I make isClick, which is basically whether or not somebody clicked on an ad, which in SQL is defined as binary, so it's only ever going to be a 0 or a 1. If I make this a category instead of a number, then my machine learning algorithm will treat it that way, and that will be an improved, will allow to have more improved results. So it's kind of the data preparation that I want to do to provide the data types that will give me a more valid result. Another kind of analysis that I'm doing is for another group of data, and I'm going to make all of these various items categorical as well. And these particular items, yes, I could have done it all together, are position, time slice, object type, and level. So time slice was actually the output of the SQL that was generated, and so we created that as a thing as well. So we need to do this in order to prepare our data, and the reason that we have, and the last thing that we have to do, we have to tell it what we're going to be evaluating. And what we are going to be evaluating is that we are, in this step, that we are going to basically make these categorical as well. Sorry, I got over myself. Next thing that we're going to do is we're going to split the data up. So we're going to split the data up into part of it that we're going to test, and part of it is going to be our control group. If you look at machine learning, if you look at the kind of analysis that we can do on this, you can start to become kind of overwhelmed when you start looking at the options that we have to do some of this validation. So some of the things that we can do, I'll go ahead and type the letter 2 because it'll show me where I can pull up all this data. So you see, these are all the ones that start with TW, but if I could also go to initialize model and take this out, I can see everything that's available to you. Oops, go back here. And there's a number of things that I can pick. Well, how do I know which are the valid ones? You know, if I've got a bunch of samples, what algorithms should I do? You know, what are appropriate? Well, what are appropriate, you can basically look at the outcomes, and we're going to go ahead and change models in order so that we can look at the outcomes of some of our experiments and see how we can determine what is a good decision model to determine which is a more effective result. So what I'm going to do is I'm going to look at a model that I previously created, and this model is a bit of a mess because I did them all. So when I was evaluating in a binary decision, what I wanted to know is which is the best one, and I didn't trust my ability to be able to understand which one was good or not. So what I did is I ran all of them. And I'm going to go ahead and try to zoom in here so that you can see this. And yes, this is kind of a mess, but I didn't, you know, I'm not like I did have to code all this by hand. And so what I can do is I can go ahead and visualize this. I need to do it on a running model, so I'll do another one. So I can determine which of all these models is the most successful model for me to pick. So I don't necessarily have to know which model. I can evaluate and find out which is the correct model. I'm going to go ahead and show you what some of the results would look like to determine what is a good model. So what I'm going to go ahead and do oops, sorry, wrong one. Problem with too many models. So what I'm going to do with this model is show you show you the what I got results. So I have two different classifications here, and you'll notice I've got green checks on all of these, and I'm going to see how successful was my model. So I'm going to go ahead and look at this model and say visualize. And what I have here for this model is I have my scored probabilities, and this tells me how close I was to the truth. So I have this is my outcome to say whether or not it's true or false. Well, if I go ahead here, I can go ahead and evaluate my model. And when I visualize it, I see two different graphs. And these graphs tell me how successful that I was at predicting the outcome. This line here is a coin flip. So this, if your model is at this coin flip line, you've not done a very good job. You can flip a coin and get results than you are. Obviously, the best thing would be if you were right all the time. Of course, if you were right all the time, I would kind of wonder if your data was screwed up, because that happens like a perfect golf game. I mean, 18 holes, 18 strokes, yeah, that never happens. And so with a model that's all one, I'd kind of have the same kind of analysis issues. So what I'm looking for is I'm looking for the biggest amount of gap that I can. And the model that provides the biggest amount of gap, it will show me that it is the most accurate. Well, that's this red one here, and the red one was the one on the left. So if we go ahead and look, the one on the left was a two-class decision forest. So given our data set, that has proven to be the more efficient model. To show you what else that we can look at here, what we do is it shows us a number of true positives, false positives, and true negatives. So in our result, the outcome was, is it true or is it false? And we can see that if it was true, actually we matched exactly 86 times for true and 134 times for false. So that's telling us that we did a pretty good job of this evaluation. And of course, which one we get the numbers for has to do with which one that's highlighted. So if I look at the one that's in red now, I can see that I have even more true negatives than I did with the blue one. So I'll just go back here and see how I had much less. That's why I have the different results, and that's why this one is the more accurate model. So this allows me to create a model which I can go ahead and use for me to predict whether or not I've got a very successful graph. And using SQL Server, I can both store my data and store my results. And what I would be storing would be the information that I would find here. My output would then be this decimal here at the end. And my decimal here at the end would tell me whether, or by scored probabilities. And what it's telling me is based on the values of all of my variables, whether or not whether or not it was true or false. So this is the outcome that you have is an actual number to determine how probable the outcome is based on our machine learning model. So that is actually what we're trying to get out of it. And as you can see, there's a number of samples available to you if you want to get started, and also the ability to pick models that currently exist so that you can do that. So once you are ready to create a model, you can do is you can prepare a web service. If you click on this, it will go ahead and create a RESTful API that you can use to either call an Excel spreadsheet, in a website, or just basically write in data fact pipeline, and that way you can write your information back to SQL Server. So now that we've looked at it, if you're looking at, you want to improve your results and you want to have a really successful outcome, one of the things that's important to do is to have a clear set of goals. I mean, if you don't know what you want to do, I guarantee you won't get a very good result. You have to have a very clear question that you're trying to resolve to be able to get a very successful machine learning outcome. It's important to have good data. If you have bad or missing data, you cannot use it in a machine learning experiment. You need to understand your data, understand all the variables that are possible to impact the results. I was talking to an insurance company recently, and they told me that they have determined that if you have a pet, you're less likely to submit a claim. Now, they know that because they're very familiar with the data, but kind of information that you would need to know in order to determine what set of variables you need to include for your machine learning model. And that is where I think that we, with the SQL Server community, do a really good job. We know the data. We are uniquely positioned to do very well with machine learning, which is great because there's not enough data scientists to go around anyway. So what we want to do is that we want to choose the appropriate method, evaluate the results, and repeat until satisfied. I showed you a model that had every single possible algorithm. It's not very difficult to do. As a matter of fact, you can use that as a template and do that for many data sets, but it's important to evaluate it to the best of your abilities. And is that using every single algorithm Microsoft has? Hey, go for it. That way you can be sure that you've got a good outcome. It's also important to keep on looking at your results over time, because as we know with things like FICO scores, hey, things change. And so just because it worked for a while doesn't mean that your model is still valid. So in summary, I hope that I've given you enough to do some analysis machine learning, showed you a little bit about how you can use SQL to clean the data. I talked a little bit with using Data Factory to get to the results of your projects that can be added back to SQL Server database regardless of where your SQL Server database is, which I think is really important. And that's pretty much what I had. Are there any questions out there?
Yes, there is. The first thing I'll get to is, what about data mining algorithms offered in SSAS? How are they comparing with Azure?
With analysis services data mining, there are 9 different algorithms that it has available for you to do algorithms. What the difference between data mining and machine learning is, it's only one type. It's basically looking at a grouping for a set of results. With machine learning, it's more open-ended. So kind of in answering to the question, you can do everything that you can do, all of the analysis that's possible to do with data mining and a whole lot more. So you can do everything that's available plus more. Any other questions?
Yep. Is it possible to try Azure Machine Learning, and if so, how?
Azure Machine Learning is available for free. So what you want to do is you want to go to Microsoft Azure site, which I did here. Go to Microsoft Azure Machine Learning Studio, Azure.net, and sign up. It's free. So using any Microsoft ID will get you started. They've got samples that you can walk through. There are videos. I really encourage you to do it because there's no cost to you to get involved in this. It's awesome. Are there any other questions? I'm kind of cool with this. I mean, there's even, not only is there even sample experiments, there's sample data sets. All these data sets here, and I'll go ahead and show this to you here in a second, are available to you so you can play with them. So the under saved data sets, these are all the samples that come with it. So even Bill Gates' red, green, blue image, which of course they put in there. But all this information is available to you just if you want. This is just data for you can play with. So if you want to do some machine learning analysis on a data set of IMDb movie titles, hey, it's out there for you for free. I also, if you're interested in learning with it, I strongly suggest looking at Channel 9 because they've got a number of videos regarding Azure Machine Learning. Are there any other questions? Aaron, are you still there? Well, I'm guessing that Aaron's experiencing audio difficulties, so I guess I will probably close this out since I don't know what anybody else has said. Hold on, I'm going to open the chat window, see if I see anything. To answer the question regarding when and how we can watch the recording, that was posted next week. All of the recorded sessions will be available, and you will be receiving an email to find out when. Hey, Aaron.
Hi, Ginger. I can jump in here and ask some of the questions.
Can you all hear me now?
Yes.
Finally, there we go. All right, can you recommend any books?
I don't recommend any books because I personally haven't read any, and I find the online documentation to be more current. There's a lot of things with machine learning that has changed quite a bit, even within the last 6 months, and I find some of the dead tree version of the stuff gets sort of stale. So the most valuable information that I've found is on Microsoft's Azure Machine Learning site and in their blogs.
All right.
I think another question is how widely is this being used now? To answer that question, I do not know. I can tell you that one of the most common tools to be used for machine learning is a tool called MATLAB. And if you have $1,000, I highly recommend you go get it. I'm cheap, and it has a much steeper learning curve, so I'm going to stick with Azure Machine Learning.
Right. Can you recommend any Machine Learning 101 resources for SQL Server veterans who are newbies to ML?
You know, that's the stuff that I've found to be the most helpful has really come from Microsoft's site. I know that I haven't seen anything in particular that they're targeting towards people with a SQL background, which I don't get because honestly, I really think that we're best positioned to do a lot with machine learning since it's data classification. Hello, that's our wheelhouse. I have a blog which is Desert Isle SQL where I've been writing about machine learning, and I hope to be doing more. And I have a SQL background, so I'll definitely be writing with a SQL Server background in mind. But I haven't really seen a whole lot that I think is targeted towards us, which I think is too bad.
All right, and next we had, is Azure ML production ready? How widely is this being used now?
Well, I would say it would be production ready if I hadn't gotten these errors today, but this really didn't help it. But and these didn't go away, and I didn't have anything to do with why they appeared. So until I saw this, I had a different opinion of it, but it is considered GA, so it has been released.
All right, excellent. What is your blog? If you could repeat that.
My blog is Desert Isle SQL. And I'm sure if you look up my name, Grant and SQL, you'll find it if you can't remember Desert Isle SQL. And I have a post there today about supervised learning, which is one of the two big classifications for machine learning types.
All right, and then just a lot of great thanks. This was an excellent intro, things like that.
Yeah, somebody also mentioned Virtual Academy. That is a great site too, and I'm sorry that I forgot to mention it because I have looked at their stuff as well.
All right. That looks like all we've got for right now.
Well, I'm really happy that I was to be selected for the new speaker edition of 24 Hours of PASS, and thank you very much, Aaron, for presenting, and I'm glad that all of you attended, and I hope that you got a lot out of it.
And thank you for your presentation. If you could put it on to the second to last slide.
Certainly.
I'll close this out.
All right. We were on the last slide.
There we go. Thank you for attending Data Analysis into SQL Server with Azure Machine Learning. I'd like to thank Ginger for her time and her expertise. Again, I'd like to thank our presenting sponsors, Microsoft, Cisco, and Dell Software, and our supporting sponsors, SQL Sentry, HP, and SolarWinds. We hope you enjoyed this session as much as we did. Follow along on social media with the Pass 24 HOP Twitter account and share your thoughts on the event with hashtags Pass 24 HOP and SQL Pass. Stay tuned for our next session, Everybody Counts, Why Your Data Type Choice Matters with Andy Yun, happening in a few minutes.